How can a pressure transmitter send its 4 to 20 milliamp measurement and digital diagnostics through the same two wires without one corrupting the other? By the end of this video, you will understand the analog layer, the digital HART layer, the two tones that carry data, and the field conditions needed for reliable communication. The key mental image is simple: a steady current with a small digital ripple riding on top. Start with the familiar analog layer. This example pressure transmitter, PT101, is configured for 0 to 10 bar. At 0 bar, it sends 4 milliamps. At 5 bar, it sends 12 milliamps. At 10 bar, it sends 20 milliamps. The analog input measures that steady direct current and scales it into pressure. In normal point-to-point operation, this current remains the primary process value, even when HART communication is added. Now magnify the signal on the wire. HART adds a small alternating waveform above and below the steady current level. The digital waveform is approximately 1 milliamp peak to peak and has approximately 0 average. That means it does not intentionally raise or lower the 12 milliamp process value. A normal analog measurement path recovers the steady current, while a HART modem detects and decodes the faster digital ripple. The drawing is conceptual and not to scale. The digital method is called frequency shift keying, or FSK. HART uses two phase continuous tones. 1200 Hz represents binary 1, and 2200 Hz represents binary 0. The data rate is 1200 bits per second. The transmitter and host do not need another cable. Their HART modems convert digital messages into these two tones, place them on the loop, and then recover the bits at the receiving end. Classic wired HART communication is bidirectional, but the digital exchange is normally half-duplex. A host, such as a handheld communicator or a HART-capable control system interface, sends a command. The addressed field device replies after the request ends. The reply can include the digital process variable, engineering units, configured range, device tag, identity, status, and diagnostics. Exact information depends on the instrument, its device description, and the supported HART revision. Quick check. The loop is reading 12 milliamps. When HART communication begins, what should the analog input read? About 12 milliamps, 4 milliamps, or 20 milliamps? Think about it. The answer is about 12 milliamps. The small FSK waveform rides above and below the steady level with approximately 0 average, so the analog process measurement remains available while the digital message travels. A technician can connect an approved HART communicator in parallel at a suitable loop connection point. In this example, the communicator reads PT101, 5.0 bar, 12.0 milliamps, a 0 to 10 bar range, and device status. Before connecting anything, follow plant SOP, PTW, area classification requirements, isolation requirements, PPE, LODO, and supervisor instructions. Use only approved equipment and connection methods, and never disturb energized process wiring unless the procedure permits it. An ordinary analog input may read 12 milliamps and display 5 bar, but it does not automatically decode HART data. Digital access requires a compatible HART modem, HART-capable input channel, or separate multiplexer and software. This distinction matters during troubleshooting. A healthy analog value does not prove that digital communication is healthy, and a lost HART connection does not automatically mean the process measurement has failed. Suppose the DCS still shows 5 bar with good analog quality, but the communicator reports no device found. HART needs a compatible signal path and sufficient loop impedance. Many devices specify a minimum total loop resistance near 250 ohms, but the correct requirement comes from the installed device load chart and system design. Also check transmitter terminal voltage, connection points, barriers or isolators, cable capacitance, grounding, noise, host capability, and device description compatibility. Excess resistance can also remove needed transmitter voltage. Quick summary. The steady 4 to 20 milliamp current carries the primary process value. HART adds 2 FSK tones for digital bits. Their average is approximately 0, so the analog value remains available. A host sends a request, and the transmitter replies. Reliable communication needs compatible HART hardware, sufficient impedance, and adequate device voltage. That is how one pair of wires carries both a trusted analog measurement and useful digital information. Thanks for watching, and subscribe for more practical instrumentation and control videos.